Hello guys, so another VHDL lesson. In this lesson, we're gonna check the or study the quadrable 2x1 multiplexer. Okay, we're gonna check the two designs that we explored in the lecture, the behavioral one, the one that we see in front of us right now, and the other one which is basically the structure one or hierarchical one using 4 2x1 multiplexers. So let's check this guy first. It's really easy, very easy to implement. Although it looks, big here, but as we will explore right now, it's really easy. And we're gonna again look at, implement using with select when. This really powerful, like generic, very powerful, statement in VHDL. So the truth table says if E is 1, because this is the enable and inverted logic. If E is 1, then disable the circuit, the outputs will be zeros regardless of the input. Otherwise, I mean when E is 0, the circuit is enabled, then when S is 0, then Y will be equal to A. I mean Y0 will be equal to A0, Y1 will be equal to A1, Y2 is equal to A2, Y3 is A3. When S is 1, then Y will be equal to B. I mean Y0 will be equal to B0 this time, then Y1 B1, Y2 equal to B2, Y3 is equal to B3. Okay? And here is, the design from outside, the boards. You have 5 boards here. So we have A and B, each of them is 4 bits. We have S, which is still 1 bit, because this is again 2x1 max, also it's quadrable. I mean, each input and is 4 bits, and also the output is 4 bits. We have the enable bit input, and the output is 4 bits as well. Okay. Again, here the selection will be based on the select and input and the enable, because if the circuit is based on E, the output might change. Okay, if E is 0, or if E is 1, because at that time the output will be just zeros. So in here, I created a signal called SC. Again, this signal is 2 bits, S and D, the concatenation between S and D. So that's why SC is equal to the concatenation. This is a concatenation parameter in VHDL. Okay, now look, when E is a second bit, so in these two cases, the circuit is operational. The multiplexer will work, will function its function, the multiplexing. So when S is 0, Y is equal to A, as simple as that. When S is 1, the first bit, Y is equal to B. Otherwise, it will be zeros. Here it should be 4 zeros, I'm sorry. It's 4 zeros, okay? So that's basically, this design. So let's compile to check just that we are good. Now let's check the second design. Second design is really good as well. We said that they are equivalent. Here is the second one, using 4 2x1 multiplexers. So each multiplexer will take 1 bit from A and B. So for example, the first multiplexer will take A0 and B0, second one A1, B1, and so on. Okay. And all the 4 multiplexers have same selection, the S, same bit. Okay. So, and all of them will receive the same enable as well. Okay. So let's explore this guy. So we need basically the package 2x1 max with enable. That's why for in the last lesson, I showed you the max, the 2x1 max with enable input. That's why, because of that application in here. Okay. So I created a package out of it, and I included here in our design. Same entity as just this design in here without the packaging, because basically it's the same function. But now the implementation is different. This is now a hierarchical implementation. Even we don't need this signal, by the way, so you can just ignore it or comment it. So here we need 4 muxes, so that's why we have 4 instantiations here. So let's explore, for example, the first one, the first instance. The first instance will take A of 0 and B of 0. Same selection is the enable, and the output will be Y0 or Y of 0. Really easy. Second instance, A1 and B1, A1, B1, SE and Y1. Then A2, B2, SE, Y2. A3, B3, SE, Y3. As simple as that. Really, both are very simple. Both are really, very simple. And you can, of course, use here the generate statement. It will be just 3 lines. Or 1 line, of course, because we usually don't count the for loop of the generate, which is basically the for and its end. Just we count only the number of lines inside to show how much it reduces the code. So it's 75% reduction. Okay, that's basically the 2 implementations. Let's check also the test bench. The test bench is exactly the same. Okay, just the entity name is different and the instance name is different, because basically they are doing the same function with same inputs and outputs. So enable can have 2 values, 0 or 1. That's why this loop, this iterator I or counter has 2. It's standard logic 0 and 1, and it's assigned to the enable input. Selection again, it's 1 bit, 2 values. So this iterator or counter, standard logic, 2 values. Then both A and B are 4 bits. So both of them is changing from 0 to 15. So we have here another nested 2 loops for A and B. And each one is changing from 0 to 15, as we see here. Okay? So let's, compile again one more time. Okay, no errors. Let's now simulate. Should be mux Q21 version 2. Can do any of them, that's fine. Max Q. Two to 1. V2 version 2. Okay. This is the guy. Here we need, huge number of iterations. Let's make them 1000. Okay. Because each input is 16 cases, and it's basically 4 times 16 times 16. So 4 times 16 is 64, 64, 64. Oh, that's really big. So let's make the radix unsigned. We're gonna check some of the, of the outputs. Yeah, I think this is the end. Okay. We need a lot of zoom out here. Okay. So let's see. We said that here input here's the here's the input is 1. The enable is 1. Enable is 1 means the circuit is disabled. Oh, it is. I'm sorry. Yeah. So here is the input is. I'm sorry. Here is the input is 0. So enable is started by 0. So the circuit is enabled. So yeah, it will work. It will function. So let's check. When the selection is 0, here is the selection. The selection is, let's suppose the selection, Let's put the enable and selection above everything. So we said that when selection is 0, the output should be A. Okay, let's check that. So here is A. Look at A. 0, 1. Look at the same time Y. 0, 1, 2, and so on. Look. When it's 3, 3, they are moving with each other until here. When we reach the final value for A, which is 15, then S become 1 and still enable is 0, so we are enabled because this is in negative logic, as I said, or inverted logic. When the enable is 0, this is enabling of the circuit. When enable is 1, we disable the circuit. So in here, look now, it's following B. Look, 0, 0, 1. B is changing, a cycle by cycle because this is the innermost loop. So it's changing all the time. So 0, 1, and then 0, 1 again. And it's not following A. Okay. Can continue. Here now, the enable become 1. So the circuit will be disabled. And the output should be 0 all the time. Look, the output is 0. All the time. 0. All the time. Okay, guys. That was basically, the quadrable 2x1 mux. Thank you very much for watching this video and see you in the next lesson. Bye-bye.